A parabolic reflector reflects all the light from the direction the parabola is pointed into the focus, a property which this radio telescope is designed to exploit. However, light which comes in at a slight angle to the direction that is pointed does not go through the focus. Instead, it is concentrated in a region, not a single point. It's this concentration, this region, that we're going to look at. So here it is. We've got a family of rays coming in at some angle to the direction of the parabola, and we see that it is concentrated in this region. We can zoom in on that region, and it is the extent of that I would like to measure, the length of this line through the reflected rays. We'll do it using the parabola y equals x squared. I know that the focus of this parabola is at the point 0, 1/4. And I'm going to put points at the edges of the mirror. The parameter f is the f number is the ratio between the distance to the focus and the diameter of the mirror. And you can check that if I use 1/8f and minus 1/8f, then this f is that f number. So if I have a ray which is in fact at 90 degrees to the x-axis here, we'll find that it reflects through the focus. However, I'd like to have rays at some other angle. We'll make it 88 degrees, and we'll look at where the rays that touch the edges of our mirror, where the reflections intersect. You can see they don't intersect at the focus, but a little bit off the focus. Now, how about all the other rays that would be impinging on the interior part of the mirror, not on the exact edge of it? Where do they go? Well, I'll create a representative 1 here at parametric location t on the parabola, that is x-coordinate t. And we see that it moves around in the region between the focus and the intersection of the rays at the extremities of our mirror. So zooming in on that, two sides of the region the line occupies are provided by the reflections of the rays that hit the edges of the mirror. The third side is the envelope of the family, this curve here. Now, the center of that envelope can be found by sticking a point on it and giving it a parametric location on that curve of 0. That is the place where the reflection at the center of the parabola passes through. So to get a measure of the amount of aberration here of that distance EF, we can look at the distance EF, and we can also look at the distance between F and the focus A. Now, if we take the ratio of those two quantities, that will give us the aberration as a proportion of the distance from the center of the image. And we see that that is the quantity in terms of the F number of the mirror.